ES Audio.
From the Evening Standard in London, I'm Rochelle Travers, and this is The Leader. Last November, UCL researchers suggested that a number of frontline London medics at high risk of contracting COVID-19 were able to avoid infection, possibly because they previously had a cold. Now, a new study from Imperial College London has found that high levels of T cells from common cold coronaviruses could provide protection against COVID. And some Londoners stepped up to play a crucial part in the research, despite the risk. The study began in September 2020, when most people in the UK had neither been infected nor vaccinated against coronavirus. The hope is the findings could help future-proof COVID vaccines. I'm joined by Imperial College London's Dr. Rhia Kundu, the study author. Dr. Rhia, tell us about your research.
So in our study, we were interested in why some people who've been exposed to SARS-CoV-2, the virus that causes COVID, why some people who've been exposed go on to become infected, become ill, potentially become seriously ill, and others don't get infected at all. So we wanted to understand why that is. And to do this, we set up what's called a household contact study, where we identify a positive case and we ascertain that that person contracted the virus outside of the house. And then, with the permission of the household members, we go in and we sample the very close household contacts of this confirmed index case. So we take biological samples from them, we find out about them as people, who they are, gender, age and sex and BMI and so forth. And then we use these samples and this data to try and understand why some members in the household got infected and others didn't. For my part in the study, I was particularly interested in cross-reactive T cells. So T cells are immune cells within our body that can recognize invading pathogens. And I wanted to understand whether, as has been shown previously, whether pre-existing T cells that could be primed by coronaviruses that are quite mild and cause the common cold usually, whether these T cells were present in people in our study and whether they were associated with protection from infection or less severe symptoms.
And what were the findings?
So what we found was that individuals who remained PCR negative during the course of our study, having been clearly exposed to SARS-CoV-2, that a number of people who remained PCR negative had higher frequencies of cross-reactive T cells. So these T cells were unlikely to have been caused by SARS-CoV-2 because these samples were taken very early on in the pandemic. These people had no prior history or suspicion of COVID in the household. And when we look at the targets of these T cells and we look at the sequences, we can see that the sequences are shared between SARS-CoV-2 and common cold coronaviruses. So it suggests that these T cells have been primed by common cold coronaviruses. And the participants who had these higher frequencies of common cold coronavirus specific T cells that also cross-reacted with SARS-CoV-2, they didn't get infected. So there was a significant proportion of our contacts who didn't get infected. Not all of them had these T cells, but a significant minority did have these T cells.
What can we take away from these results?
So for me, I think the interesting idea behind this is that these T cells target a part of the virus that largely cannot change. These targets are present in the common cold coronaviruses and they're present in SARS-CoV-2. To date, it really suggests that the virus cannot do without these targets. And if we can design vaccines that target these parts of the virus, we could be generating a next generation vaccine that could provide protection against multiple variants. So currently, a significant part of the protection from vaccines is related to the spike protein and providing a neutralizing antibody response. And this is a strong selective pressure. And what we see in flu is that this can drive the drift of the virus or emergence of new variants. So it moves away from the sequence that alerts the immune system to it, and it takes on a different identity to try and disguise itself or hide itself away from the view of the adaptive immune response. But if we can design vaccines that target the parts of the virus it can't change, it can't do that. It cannot hide. So that's the hope of a vaccine that targets these internal genes, these internal proteins, that it cannot hide. It cannot run away from that response.
So what happens next?
For me, my hope is that this can provide a blueprint towards a second generation vaccine that could target all variants that might emerge in the future and future-proof our vaccine program. So we need larger studies. I think the work that we've taken inspiration from and the bioinformatic work that we've done to identify targets for these cross-reactive epitopes and the proof of principle that our small study provides, I think these form the basis for doing larger population-based studies where we assess the prevalence of these T cells in the population and confirm the results by seeing whether people who have these T cells are less likely to be infected, less likely to have more severe symptoms, and so forth. And then from there, there's promising technologies coming forward in terms of T cell vaccines. So literally try and induce the T cell response in the vaccine, or look to use these targets to validate other technologies that might induce responses against these conserved components of the virus.
And you're keen to highlight the significant role of both the team involved in the research as well as the Londoners who took part in the study, aren't you?
It was incredible. It was hard work. The team behind this study are absolutely incredible. And when you think about what they've achieved and what they've done, we were at the start of the pandemic when we were setting this up and establishing the study. We didn't know what this virus was that had come on our shores. We were in February, March, and we were hearing only that the first few hundred cases were being recorded. We as a team didn't know what this virus was going to do and how it was going to behave. And the reason we've been able to make this observation is because our team get to these exposed individuals so quickly. Our team get to these potentially infectious people within 3 days of the symptom onset in their index case. So this is peak kind of risk for our team, but also the participants who've volunteered to take part. And for me, I've always amazed at what the participants have done to take part in this research. You're at the start of a pandemic, you're infected with a virus, we don't know anything about it. You could pass it on to your loved ones, and someone rings you up and says, can I come to your house and take your blood and ask you all these questions? And the people in London that took part said, yes, I will. And that's really brave.
And that's it from The Leader. This podcast is back tomorrow at 4 p.m.